Okay, so question 1. Because we did the basics, so you can just go straight to the questions. Question 1, given f of x is equal to 1/16 to the power x. Evaluate. Evaluate a f of -2. So if I'm given f to be 1/16 to the power x, you can as well write f as f of x is equal to 16 to the power -x. So that here we'll now do is 16 to the power negative, x is -2. So we have 16 squared, which you can find if we evaluate. So me here, I'll use the calculator, 256. For you guys, you multiply 16 by 16. So the idea is just to substitute where there is x, you substitute like that. Then we go to b, we do f of -1/4. Again, 16 to the power -1/4. So we get 16 to the power +1/4. This is like the fourth root of 16. 2 times 2 is 4 times 2, 8 times 2, 16. So we get 2 here to be the fourth root. So it's like you're talking of where did you get the 2 from? The fourth root of 16. So it's like you can write this one, you can write it as 16 square root of the square root. That's what it means to be the fourth root. So the square root of 16 is 4. And then its square root is 2.
Why did we put 16 to the power -4?
No, why negative? No. Or you can write 16 as 2 to the power 4. So that you can see that it's becoming 4. How it becomes 4. So this is like +2. Like that. Okay, then see f of 0. The 2 in question 1a. We're talking about question 1a. Question 1a. No, the question is saying find f of -2. So we substitute in here where there is x. We substitute -2. That's why we had -2 here. Then the negatives made it +2. Hope is answered now. Okay, cool. We got f of 0. F of 0 is 1/16 to the power 0. Or we use the latest one, 16 to the power negative 0. But 0 doesn't care about signs, so it still remains 0. And any number raised to power 0 is 1, apart from 0 itself. So we can go to D, f of positive 1 over 4. So this is 16 to the power negative. We are bringing 1 over 4. So this is like 1 over 16 to the power 1 over 4. Remember, we have found this one to be 2. So we'll have 1 over 2. We'll have an easy time there. 1 over 2. Because we know the fourth root of 16 is 2. And if, so here I've used that property which you said if you have a to the power negative m, the same thing as 1 over a to the power m, like this. So those properties are the ones that we're using today. And that finishes the whole question 1. Very, very nice. So we go to question 2. Question 2, sketch. So sketch the graph of the following functions. A, f of x is equal to 5 to the power x. So pay attention when it comes to sketches. If you have forgotten the family shape, when I say family, I mean this. That day we said we have these shapes where you have this crossing at 1. This is a to the power x. So the video is being recorded, Martha, so don't worry. So this is the family shape. If we have this side, then it is a to the power negative x. If you are this side, crossing at -1, then it is the negative of this one. So you say negative ax. If you're coming from this side, then you say it's negative a negative x. So what's happening is that with this in mind, you can easily graph this one. You say, okay, this is in the family case. If we number them, this is 1, this is 2, this is 3, and this is 4. So you say this is in the family case number 1. So you have this still crossing at 1. We don't need so many points. This is f of x is equal to 5 to the power x. Now, what happens if you forget the family shape? So you can't remember that this goes like that. You pick simple numbers, okay? Pick numbers like -1, 0, and +1 as your x values. Then you have your f of x here. Then evaluate. So what is f of -1? F of -1 is going to be 5 to the power -1, which is the same thing as 1 over 5 to the power 1, which is 1 over 5. So we put 1 over 5 here. Then you go, what is f of 0? This is 5 to the power 0, which is 1. So we put 1. What is f of 1? This is 5 to the power 1, which is 5. So we put 5 here. Then you see that when you go to sketch, we have -1 this side, and not on that graph, I'll put it here. So you have -1 this side, the value of x, and then you have 1 over 5. 1 over 5. So you have a point somewhere here. And then you have 0, and you have 1. And then you have 1, and you have 5. So a number somewhere there. So you have these points. Then you connect them using a curve like this. So this is f of x is equal to 5 to the power x. But if you remember the family shape, there's no punishment that you get if you don't solve. You just put the sketch. These are easy sketches. You still get full marks. If you just remember and you put this, you have your full marks. And the marks not even be a lot. Maybe it's just 2 marks because there's no work here. Okay. So key for these graphs of exponentials, this is the key. We respect the asymptote. So here we have this as an asymptote. So respect the asymptote and the intercepts. Adieu.
Sir,
Yes.
I'm very confused on
Remove
why the graph,
remove the word very.
like, very confused on why the graph is not cutting the x-axis. For my little idea from the previous functions, it's like I did understood that, see, when finding the asymptote, you look for a number which makes a function undefined.
You look for a
That's the one
number
you choose.
which makes the function undefined.
Yes,
Yeah, right. That is for fractions.
that is for fractions,
Yes.
which is different from this one.
Which is different a bit from this one, but the concept of asymptote is the same. Here we are saying,
How do you find it?
here we are saying we cannot find a number that we can put where there is x there that will make this thing 0. So we can't find a number that when you substitute here where there is x, this thing will be made 0. Can you think of a number? Well, let's go for big numbers. Suppose x is -1000. What do we get? We get f of -1000 to be 1 over 5 to the power 1000. The number down is going to be very big, but 1 over any big number which is positive can't be 0. Secondly, we can't find a number that can make this whole thing negative, because if in negatives, I'm making it positive. As you can see, we have used -1000, and we're still talking about a positive number. A number that is very small but bigger than 0. That's why it won't touch the asymptote.
So is it always that our asymptote, it will be 0?
Not always.
Now, how do you know that this
so I'm
is
here
an
to give you,
asymptote?
I'm here to give you a general form now,
Okay.
so that you can answer B. So I'll take my term on B. So the general form for exponential functions is supposed to be A plus, or maybe let me use a neutral thing there. What can I say? Okay, let me the same A plus B to the power x. So we have A plus B to the power x. So the asymptote, take note that the horizontal asymptote For this f of x will always be equal to a. So it will be y is equal to a. So that we can understand that in the previous question, where we had f of x is equal to 5 power x, a here was 0 and b was 5. That's why the not asymptote was the line y is equal to 0, which is the x-axis for this question. If you look at b is g of x is equal to 5 power x minus 4. So now we see that a in this case is -4. So when sketching, we'll have the horizontal asymptote to be the line y is equal to -4. So y is equal to -4, like this. And then we need two numbers now. Because the asymptote is below the x-axis, so this graph is going to have an asymptote, it's going to have intercepts. So the first intercept is the y-intercept. So how do you find the y-intercept? How do you find the y-intercept? The y-intercept is found by letting x be 0 in G. So we'll have 5 power 0 minus 4, which is equal to 1 minus 4, which is -3. Remember, to find the y-intercept for any function, let x be 0. Then you have the y-intercept, because x is 0 throughout the y-axis. So we have gotten -3 as the y-intercept. We now need to get the x-intercept. To get the x-intercept, you equate g to 0. Let g of x be equal to 0. So we'll have 5x minus 4 is equal to 0. We have equated the whole g to 0. So now we have 5x is equal to 4. Now we need the value of x. Remember the properties. If you have log has the power to drop any power down. Then it means in this case, we'll introduce log. Now remember that we said log of a b power n is the same thing as n a log of a b. This property. So we have this. Secondly, we also have log of a is equal to 1. So here we have two options. If we want, we can just have x directly by choosing the base to be 5. So we can say, okay, let us apply the log to the base 5 of 5 power x. Whatever you do on the left, you also do on the right. So also apply log base 5, 4. So that when x comes down, then we remain with log 5, 5, which is equal to log 5, 4. So this one here, using this property, becomes 1. So we remain with x is equal to log 5, 4. So we'll have wherever it will cut to be that intercept named. So now we have a curve of this nature, touching at log 5, 4. And the whole function becomes g of x is equal to 5 power x minus 4. So once you keep this, take care of this, you won't even need the table. Once you know the asymptote, then you find the y-intercept. That is the easiest thing to find. Just let x be 0 in any function. Then the x-intercept, equate the whole function to 0. And for log, for exponentials, if x is the power, to drop it, you introduce logs. And this is how we do the introduction of logs.
So I didn't see anything there.
On how to find.
Okay.
So a bit tricky maybe is because hearing for the first time. Okay, let's go to the next question, then you'll see. Maybe you pick some more concepts. We still have question 3 based on the same thing. Even question 4 based on the same thing. So we have a lot of the same kind. So I'm moving to C. So moving to C, we have h of x is equal to 5x minus 3. We want to sketch, but we know the formula already because x is positive there. So to sketch this guy, maybe we just need to find the y-intercept. What is h of 0? That is 5 to the power 0 minus 3, which is 5 to the power negative 3, which is 1 over 5 power 3, which is 1 over 125. So then we sketch. So the family is the same. This is the family because a is 0 there. So we maintain the x-axis of the asymptote. And that has changed is the intercept. We have 1 over 125. The other things we don't care. So the asymptote is the x-axis because a is 0 in this case. So whatever goes to the power must not affect the shape. It must not affect the asymptote. So since we said it must be a plus bx, and this will be the asymptote. Now we can't see a here. Whatever is there is on is the power. So if it's the power, it's not worrying us. That's how easy this sketch is. So maybe in general, what we pick from this one is that one, just remind you to find the y-intercept, substitute x is equal to 0 in the function given. Two, to find the x-intercept, to find the x-intercept, to find x-intercepts, equate the function to 0. 3, I said if f of x is equal to a plus, maybe I put another one, c and b power x, where c is the coefficient of b to the power x. The horizontal asymptote is the line y is equal to a. If a is 0, then the x-axis is the asymptote. Okay, so this was answering question 2. And we picked a few notes here to find the y-intercept, the x-intercept, and the horizontal asymptote. And the shapes are there on the first page. These are the shapes. Coming on the second page. So if we do question 3, A, we are still sketching here. I want to sketch f of x is equal to 1/3 to the power x. Need to be careful a bit when it's a fraction of this nature, because this guy can be written as 3 to the power -1 inside, and then power x, which becomes 3 to the power -x. So when this is the case, then you know that the family has changed now. We're dealing with this setup. So we're dealing with the second function, family number 3. While the orientation of the curve changes. So we're now saying that what we have is a shape with a 0. So the x-axis is the asymptote. And then the family shape is this one, where this guy is still 1. Well, again, if you have forgotten the family shape, then you put numbers -1, 0, 1 as your x values, and then your f of x. Then how does it come out? So you have f of -1 to be 3 to the power -1, which is 3 power 1, which is 3. So you substitute 3 here. You do f of 0, that is 3 power -0, which is 3 power 0, which is 1. So you put 1 there. F of 1, that is 3 power -1. So we have 1/3. 1/3. So you see that when you have 1, you get a small number, 1/3. When you have 0, you get 1. And when you have -1, you get 3. Somewhere here. So your curve will still be guided by those numbers. So why using -1, 0, 1? They are easy to calculate, and they represent the negatives and the positive behavior. 0 gives us the intercept. What about B? G of x is equal to 1/3 power x plus 2. So here you have seen A is equal to 2. So what does that mean? That means that, okay, just a minute. So that means that, so it's still the same function that you can write as 3 to the power -x plus 2. So only A has been introduced. It's no longer 0 now. So the asymptote goes up. and this is 2, and then the shape will still remain that thing. So now I need to find the y-intercept. By substituting where there is x, you take 0. So we'll have 3 to the power negative 0 plus 2. But this is 3 to the power 0 plus 2. And 3 plus 0 is 1. So we have 1 plus 2, which is equal to 3. The asymptote is 3. And the shape comes out like that. So we always have an easy time there. Even when when g of x is equal to 1/3 to the power x plus 4. Well, it's still the same thing. We can write this guy as 3 to the power negative 1, and then x plus 4 as the power. If we expand, it becomes 3 power negative x minus 4. And then we'll have since a is 0 here, so we have the same shape. What has changed? The intercept. So you substitute what is g of 0. So get 3 power negative 0 minus 4, which is 1/3 to the power 4. So what is 3 to the power 4? That is 81. So get 1/81. This is 1/81. So no matter how small it will be, it still remains positive. We then disturb the shape there. Asking for the previous step. This was the previous step. So this one left blank. Like that. Okay, so we'll break off for how many minutes? This is like 9:40. That is 18:40. I think 5 minutes. No, 10 minutes. So let's join at 18:50. Maybe we'll push from question 4 up to maybe 9 and see how we go. So keep time, 18:50, be back.